Welcome to Study Loop.
The velocity of a particle moving on the x-axis over the interval 0 less than or equal to t less than or equal to 6 is given by v of t equals 2 sine e to the t over 4 plus 1. And the acceleration of the particle is given by this function a of t equals 1/2 times e to the t over 4 times the cosine of e to the t over 4. The position of the particle is x of t and x of 0 equals 2. At t equals 5.5 is the speed of the particle increasing or decreasing. That's the first thing we want to figure out. So we need to know what is the velocity at that time. So v of 5.5. So if we plug 5.5 into the velocity function, that's 2 times the sine of e to the 5.5 over 4, and then we add 1. So that's about negative 0.453, approximately negative 0.453. So the velocity is negative, and we need to look at the acceleration at that time. And acceleration is 1/2 or 0.5 times e to the t over 4, so 5.5 over 4, and then times the cosine of e to the 5.5 over 4. And that gives us negative 1.356, about negative 1.356. So we see the velocity is negative and the acceleration is negative. So we're moving in a negative direction, and the acceleration is pulling us further in a negative direction. So that means the speed has to be increasing, since the acceleration and velocity have the same sign. So it's increasing because the acceleration function a of t and b of t have the same sign at t equals 5.5. Okay, next we want to find the average velocity of the particle over that interval from t equals 0 to 6, between those times. So the average velocity would be 1 over the difference between these times, so 6 minus 0, times the integral from 0 to 6 of the velocity function, which was 2 times the sine of e to the t over 4 plus 1 d of t. So we can run that in a calculator. That would just give us 1 over 6 times the integral from 0 to 6 of 2 times the sine of e to the x instead of t, so x over 4, and then we say plus 1, and then of dx, and that gives us 1.949. So about 1.949. Next, we want to find the total distance traveled by the particle over the interval from 0 to 6. So the total distance would be the integral of the absolute value of the velocity function, d of t. So that from 0 to 6, that gives the total distance. So that would be, the total distance is the integral from 0 to 6, the absolute value of 2 sine of e to the t over 4 plus 1 d of t. And if we plug that in a calculator, so the integral from 0 to 6 of the absolute value of 2 times the sine of e to the x over 4 plus 1 and we do dx, and that gives us about 12.573. About 12.573. Okay, and lastly, the particle changed direction one time in the interval from 0 to 6. Find the position of the particle at that time. So it's going to happen whenever the velocity is equal to 0. So the velocity function of 2 sine of e to the t over 4 plus 1 equals 0. So we want to find when does that happen, and we want to find that position. So if we solve this, if we subtract 1 and divide by 2, that gives us the sine of e to the t over 4 equals negative 1/2. So if we know our trig functions, when does sine equal negative 1/2? When we're looking at this interval from 0 to 6, so we know that sine function would equal negative 1/2 if we know our unit circle. As we rotate along the unit circle, that would happen at this angle and this angle here being 7 pi over 6, and then that larger angle being 11 pi over 6. So that means e to the t over 4 would be equal to 7 pi over 6, or possibly e to the t over 4 equals 11 pi over 6. And we can see that one of these solutions will not be valid. If we solve both of these, we would take the natural log of both sides. That would give us t over 4 equals the natural log of 7 pi over 6. So t would be 4 times the natural log of 7 pi over 6. And if we plug that in a calculator, that gives us 4 times the natural log of 7 pi over 6. That gives us about 5.196. So t is about 5.196. And then the other value that would give us t over 4 equals the natural log of 11 pi over 6. So t would be 4 times the natural log of 11 pi over 6. And if you plug that in, you get like about 7.003. And that's outside of our time interval, since we know that t is less than or equal to 6. So we can ignore this solution. So that's the time we want. T equals 5.196. We want to find the position at that time. So we know that our initial position was 2. X of 0 was 2. So position at 5.196 would just be 2 plus the accumulated change in distance, or how far, based on the velocity, the integral of the velocity from 0 to that time. So 5.196 of the velocity function, which is, of course, the 2 sine of e to the t over 4 dt. So we could plug that in a calculator. So that's just 2 plus the integral, 2 plus the integral from 0. I'm just going to use that stored value in the calculator rather than rounding. And we're doing the integral of 2 sine, and I forgot the plus 1 in that when I wrote that down. So 2 sine of e to the x over 4 plus 1, and we have the dx, and that gives us 14.135 if we round to 3 decimal places. So it's about 14.135 is the position when the particle changes directions.